Sometimes we have a system of equations that don't have a plain x or a plain y, and if we tried to rearrange it and solve it, we'd have a bunch of ugly, nasty fractions to work with. Not that you couldn't do that, but it's a lot harder to work with fractions. So this method is called the elimination method. What you're going to do is you're going to multiply either one or both equations times something so you get opposites, either in front of your x or in front of your y, so that when you add the two equations together, you can cancel out one of your variables. So you look in front of the x's and say, okay, what is my least common multiple of 6 and negative 3?
3.
Multiple.
Oh.
6 would be, right? So if I wanted to make these opposites, since this one's already 6, I would multiply the bottom equation by 2. Because if I multiply the bottom equation by 2, I'm going to get a negative 6. So one will be 6, one will be negative 6, and they'll be opposites of each other. Now when I multiply, I have to do the whole equation. So the top equation is going to stay the same. 6x minus 5y equals 18. The bottom equation would be negative 6x. 2 times 4 would be plus 8y equals 2 times negative 18, so negative 36. Now what I'm going to do is add my equations together. When I take 6x minus 6x, it's going to cancel out, right? I get 0. Negative 5 plus 8 would be 3y. 18 minus 36 would be negative 18. In order to solve that, all I'm going to do is divide. Y is going to equal negative 6 then. Now, in order to find x, I don't have an equation that just says x equals something. What I have to do is just pick either one of those two equations and substitute the negative 6 in for the y. Does it look easier to use the top one or the bottom one? Top one? Okay, so I'm going to use the top one. The top one says 6x minus 5y equals 18, but I know that y is negative 6. So if I simplify that, negative 5 times negative 6, positive 30. So I have 6x plus 30 equals 18. If I'm going to solve that, I've got to move my 30 to the other side. So I'm going to minus my 30. 6x then would equal negative 12. And then, of course, I have to divide by 6. So x equals negative 2. And again, if I wanted to double check and make sure my answer was right, I'd check it in my other equation. Negative 3 times negative 2 would be 6. 4 times negative 6 is a negative 24. 6 minus 24 is negative 18. Yep, it checks. So those are my answers. So in this one, we only had to multiply one equation times something to make opposites. Sometimes you have to do both. Got this one all written down. So number 5 wants us to solve the system of equations. We have negative 3x minus 8y equals 6 and negative 5x minus 6y equals 10. If I want to eliminate my x's, I want my least common multiple of 3 and 5, which would be 15, right? So one of them we want to be positive 15, the other one we want to have negative 15. So we think about, well, what can I take times my top equation in order to get a positive 15? We can multiply that by a negative 5. Since I made the top equation positive 15, means I want to make my bottom equation negative 15. So I think about, well, what do I take times negative 5 to get negative 15? I'd have to have a positive 3. I'm then going to multiply that whole top equation by negative 5. Negative 5 times negative 3x would be 15x. Negative 5 times negative 8y is positive 40y. Negative 5 times 6 is minus 30. On my bottom equation, multiplying everything times 3. 3 times negative 5x would be negative 15x. 3 times negative 6y is negative 18y. And 3 times 10 is 30. So if I add my equations together, my x's are opposites. I've got a positive 15 and a negative 15. Those are going to cancel out. 40 minus 18 gave me 22y. And negative 30 plus 30 is 0. So if I take 0 and I divide it by 22, we still get 0, right? It's okay to have an answer of 0. Y can equal 0. So if I get an answer of y equals 0, I still need to go back and find my x. I can put it in either equation. Which one looks easier to use? Top or the bottom one? The bottom one? Okay, we'll put it in the bottom one. Negative 5x minus 6y equals 10. If y is 0, what happens when you do negative 6 times 0?
0.
You get 0, that's basically just going to be gone then. Negative 5x equals 10. And then in order to solve that, we would divide by negative 5. So x is going to equal negative 2. If I want to check that, since I used the bottom one over there, I need to use my top one. Negative 3 times negative 2 is a positive 6. Negative 8 times 0 is 0. 6 plus 0 is still 6. So those should be my answers. So I'm thinking she just typed that in. So looking at number 6, if I look at getting rid of the x's or getting rid of the y's, what would you rather do?
We'll do the x.
Do the x. So if I'm thinking about my least common multiple of 9 and 3,
9.
it'd be 9. That means I don't need to take the top times anything because it's already negative 9. Negative 9x minus 7y equals 1. But what should I take the bottom equation by? Negative 3. Why do I want to use negative 3? Because I want to get a positive 9. Negative 3 times negative 3x would be 9x. Negative 3 times a negative 2y would be positive 6y. And negative 3 times a negative 1, positive 3. So if I add those two equations together, I'm going to get negative 1y equals 4. And when I divide then, y equals negative 4. So once I find y, I have to go back and find x. Which equation looks easier to use, the top one or the bottom one? Bottom one looks easier to me too, the numbers aren't as big. So we have negative 3x minus 2y equals negative 1. We know that y is equal to negative 4. So if we multiply that out, we would get negative 3x plus 8 equals negative 1. If we're going to solve that, we would then minus 8. So negative 3x equals negative 9 then. And then we're going to divide. X equals 3. So just quickly checking that. Negative 9 times 3 would be negative 27. Negative 7 times negative 4 is a positive 28. Sure enough, negative 27 plus 28 is 1. So it checks out. We know we did it right.